Congratulations! We are the Group 1 and we are here to teach you on how to solve problems in physics.
Are you struggling to solve problems in physics?
Don't worry, we are here to help you and we are going to give you tips as well.
For our first problem in horizontal motion, what is the distance covered by a bike from rest and runs 50 meters per second within 8 seconds? To solve for this problem, we have here the uniformly accelerated motion formulas.
But before you choose a formula, let's analyze the problem first.
In this problem, it is asking for the distance covered by the bike. So that's what we need to identify.
At the same time, we have the word rest, which means it is not moving. This is what we identify as the initial velocity. We also have the word runs, which means the vehicle is moving, so we have a final velocity of 50 meters per second. Lastly, the 8 seconds will be our time.
Since we are done identifying the given, let's identify the formula that we are going to use. We have the formula of D equals Vf minus Vi divided by 2 times time.
To solve for this, you have to substitute the given for the formula.
After you substitute, now you have to solve. We have 50 meters per second minus 0 meters per second. Then we are going to divide it by 2. Then we'll have 25 meters per second.
After we have the 25 meter per second, you have to multiply it by the time 8 seconds. Then we'll have the final answer, which is distance is equals to 200 meters.
There we have it. Was it hard? Well, if your answer is no, we have another problem for you.
For our second problem, a car accelerated from rest at 17 meter per second squared for 10 seconds. A. What is the position of the car at the end of 10 seconds? B. What is the velocity of the car at the end of 10 seconds?
Same procedure as the last one. First, identify the givens. Accelerated from rest, which means we have initial velocity is equals to 0 meters per second.
Next, the acceleration itself for 17 m squared and the time for 10 seconds.
Now, the formula that we are going to use, since we are finding in the letter A, is position of the car at the end of 10s, is D equals VIT plus 1 half 80 squared.
Again, let's substitute it. We have the initial velocity from rest, which is 0 meter per second, and time, which is 10 seconds. For the acceleration, we have 17 meter per second squared, and time 10 seconds. But since we have the square there, we are going to multiply it by itself.
First, multiply the 0 ms and 10 seconds. Then we get 0 ms because anything you multiply to 0 become to 0. And next, let's square the time. Well, you have 100 because 10 times 10 is equals to 100.
Let's continue it by multiplying the 100 seconds and 17 meters per second squared.
If you are wondering, the acceleration unit has squared too. Are we going to square it too? The answer is no, because that squared is part of its unit.
Going back, if we multiply 117 meters per second squared, we'll have 1,700. Now for the last part, multiply it by 1 half or 0.5 and the final answer is 850 meters.
Since we already have the given values, let's identify the formula that we are going to use. Since the problem asks for the velocity of the car, we will use the formula of Vf is equals to initial velocity plus acceleration times time.
Again, substitute it. 0 ms for Bi, 17 ms squared for acceleration, and 10s for time.
Multiply the acceleration and time first. Then we'll get Vf equals 170 meter per second.
And that's it. That's how you solve horizontal motion problems.